Now next topic is rule of integration. By parts. Rule of integration by parts. Say, rule is, let u be a function of x and v be another function of x. U and v are two functions. Then integral of product of u and v, integral of u into v is equal to u as it is, first function keep as it is, into integral of second function. Keep first function as it is into integral of v, then keep minus, then integral of, then here I keep bracket. See how to remember this rule. U as it is, integral of v minus integral of bracket. Now what is bracket? Bracket contains derivative of u into integral of v with respect to x. So second term is integral of product of derivative of u and integral of v with respect to x. So look here, in this rule we are taking derivative of u, and in first term and in this second term we are taking integral of v. So second function we integrate. Now to understand this, taking question, obtain integral of x into sin 3x dx, x into sin 3x dx. Now take x as u and this as v. We are taking x as u because when we differentiate u with respect to x, its derivative will be 1. So this becomes easy. So this is u, this is v. U as it is, integral of v, u as it is, integral of v minus integral of box, u as it is, integral of v minus integral of box. Now in box what we are putting? Derivative of u, u is x, integral of v with respect to x. So application of this formula, use here bracket. Second term is integral of this box with respect to x, integral of box with respect to x. Now box includes derivative of u into integral of v with respect to x, and whatever is product of this derivative and this integral, then we take integral of this product with respect to x. So it is equal to x into, now its integral is, integral of sin 3x is minus cos 3x upon 3. Integral of sin 3x is minus cos 3x upon 3 minus integral of, now here say here coefficient of x is 3, so divide by 3. Supposing this as x, integral of sin x is minus cos x, but this is not x, it is a, consider it as ax plus b. So divide coefficient of x to this integral, so minus cos 3x upon 3 minus, here this is 1 into this is minus cos 3x upon 3 dx. Now see, when we are putting integral of second function, we do not put here plus c. See here also, when putting integral of sin 3x, we do not put plus c. Plus c put at last when you remove last symbol of integration. So when putting integral of this box value, at last we will put plus c. So remember, applying this rule, putting integral of v don't include constant c. Put at last when removing this outer symbol. So it is equal to minus x cos 3x by 3 minus minus plus 1 by 3 cos 3x dx. So it is equal to minus x into cos 3x by 3 plus 1 by 3 into, now integral of cos 3x is integral of cos 3x is sin 3x upon 3 plus c. Plus c keep when you remove this last symbol of integration. So cos 3x, its integral is sin 3x by 3, then last keep plus c. So this will be 3 into 3, 9. So directly we can keep here 9. So this is required integral. Now one more question. Suppose we want x into log of x dx, x into log of x dx. Now see, choice of first and second function. If you consider x as u and log x as v, then what will happen? If you keep here log x if you suppose as v, then you have to put here log x, you have to put here log x. And we don't have formula for integral of log x. So then procedure will be stopped because we don't know what is integral of log x. So in this case, what we will do? Log x take as v, log x take as u, and x you take as v. Log x keep first, x keep second. So choice of first and second function is very important. Remember one rule. See, LIATE. Remember one key point. LIATE. Choose u and v according to sequence of these letters. L means log function. L, that is log function. I, that is inverse trigonometric functions. Inverse trigonometric function. A, that is algebraic functions. Algebraic functions means x square plus 1. These are algebraic functions. T, that is trigonometric function. Sin x, cos 3x. E, that is exponential function. Exponential function. E raised to x, like that. So now say log x. So L is on left side. Algebraic function, LIATE. say here x is algebraic function, x is algebraic function, log x is log function. Now observe this sequence, which is on left, log x is on left and x is on right side. So this should be taken as u and this should be taken as v. So this is u, this is v. This is the trick to integrate easily, to apply this rule of integration by parts. So remember LIATE. Choice of u and v, choose u and v according to sequence of LIATE. So this is u, this is v. So u, v. Now applying this rule, u as it is, integral of v, this is v, minus integral of box, now in box, derivative of u, that is derivative of log x, integral of v, integral of v, integral of v with respect to x. So this is log x into, its integral is x square by 2. We don't keep plus c. Here we don't keep plus c. So remember, when putting integral of v, we don't join plus c. C we will keep at last when removing last symbol of integration. So don't join here c. Then minus integral of, first of all simplify this bracket. In this bracket, derivative of log x is 1 by x, integral of x is x square by 2 dx. So this is log x into x square by 2 minus 1 by 2 take outside, this is x. Now see, simple integrable. So when removing this symbol, we will keep plus c. So it is equal to x square by 2 into log x minus 1 by 2 into integral of x is x square by 2, 2 into 2, 4 plus c. So sometimes this trick is useful. Algebraic functions, that is x, x square plus 1, such functions are algebraic functions. Trigonometric functions, that is sin x, cos 3x, sec square x, such functions are trigonometric functions. Inverse trigonometric function, that is sin inverse x, tan inverse x, etc. These are inverse trigonometric functions. Log functions, that is log x, log of x plus 1, such are log functions. Exponential functions, e raised to x, e raised to 3x, 2 raised to x, etc. L, I, A, T, E, these are groups. So whatever is first, consider as u, second as v, according to sequence of LIATE. Integral of x square into e raised to x. Say look, this is algebraic function. Say LIATE. Now x square is algebraic function. E raised to x is exponential function. So this should be on left side, this should be on right hand side. U first function, v second function, and already in proper sequence. Otherwise, if this is printed on left side, this is on right side, then you have to rearrange as this sequence, according to this sequence. So it is already properly given. So now this is u, this is v. U as it is integral of v, u as it is integral of v minus integral of box. In box, derivative of u, so derivative of x square into integral of v, so integral of v, and integral of this box, that is dx, integral of box. So in box we put du by dx into integral of v with respect to x. So product of derivative of u and integral of v, whatever is product, its derivative with respect to x, that is second term. Then it is equal to x square into integral of e raised to x is e raised to x. Don't keep plus c. Plus c we shall keep at last. Minus integral of, now in bracket, derivative of x square is 2x into e raised to x. Integral of e raised to x is e raised to x. So dx. Now look. Again, this is 2x into e raised to x. So once again we are getting 2x and e raised to x. So 2x is algebraic function, e raised to x is exponential function. Once again applying same rule, considering this as u and this as v. So this is equal to x square into e raised to x minus, now use bracket because this is main sign. Now in big bracket, applying this formula once again, u as it is, this is u, integral of v with respect to x minus integral of box, changing pattern of box, pattern of bracket. Now in box, derivative of u, integral of v. So u as it is integral of v minus integral of box. In box, derivative of u, integral of v, and integral of this box, and this is second term, so use bracket because main sign is minus. So in this question, this rule of integration by parts is applied 2 times. So it is equal to x square into e raised to x minus 2x into, its integral is e raised to x minus integral of, derivative of 2x is 2, integral of e raised to x is e raised to x. This is simple form of this bracket, and this dx. Don't miss this dx. With every symbol of integration there must be dx. Close the bracket. So it is equal to x square into e raised to x minus 2x into e raised to x minus 2 as it is, integral of e raised to x is e raised to x. Close the bracket, and at last we keep plus c. So it is equal to x square into e raised to x minus 2x into e raised to x minus plus 2 into e raised to x plus c. Now from these numbers, taking e raised to x common, x square minus 2x plus 2 into e raised to x plus c. Now in this question, see, whenever you find inverse, sine inverse x, cos inverse x, tan inverse x, the better way is take help of a substitute. Here we are taking sine inverse x equal to theta. Take sine inverse x equal to theta. If sine inverse x equal to theta, then next step you put x equal to sine theta. Sine inverse x is theta, so x equal to sine theta. After putting this step, next step is relation between dx and d theta. So here dx is cos theta, d theta. Derivative of sine theta is cos theta. So putting values, now we are putting values. Integral is x. What is x? Sine theta. Sine inverse x. What is sine inverse x? It is theta. Dx. What is dx? Cos theta, d theta. Say this is x. This is sine inverse x. X into sine inverse x into dx. Now it is equal to, this can be arranged as theta into sine theta cos theta d theta. Now this can be joined. We use trigonometric formula. Sine theta cos theta is sine 2 theta divided by 2 d theta. Now look, theta is algebraic term. Theta is algebraic. This is trigonometric. Trigonometric is sine 2 theta. So theta is in group of algebraic like x. Doing with respect to theta, theta is algebraic. If you do with respect to x, x is algebraic. So theta is algebraic, sine 2 theta is trigonometric. So this is u, this is v. Now applying this rule of integration by parts. So 1 by 2. Say here what we do, sine theta into cos theta is sine 2 theta by 2. This by 2 I am including inside. Here I am putting by 2. So in the next step, theta by 2 we consider as algebraic number. So now this number we take as u, this number as v. U into v. U as it is integral of v with respect to theta. Everything in terms of theta minus integral of box with respect to theta. In box, derivative of u, derivative of theta by 2, integral of v with respect to theta. So u as it is integral of v minus integral of box. In box, derivative of u, integral of v with respect to theta. Everything with respect to theta. So application of this rule. So it is equal to theta by 2 into Now integral of sine 2 theta is minus cos 2 theta by 2. Integral of sine 2 theta is minus cos 2 theta by 2. Coefficient of 2 is divide by 2. Minus integral in box. This is 1 by 2. Derivative of theta by 2 is 1 by 2. Integral of sine 2 theta is minus cos 2 theta by 2. This is value of sine 2 theta d theta. Close bracket. Put d theta. So it is equal to minus theta by 4 cos 2 theta. Here minus minus plus 1 by 4 cos 2 theta d theta. So it is equal to minus theta by 4 cos 2 theta plus 1 by 4 into integral of cos 2 theta is sine 2 theta by 2, and at last keep plus c. Joining 4 and 2, 4 into 2 is 8. Now this is integral in terms of theta and function is in terms of x. Here we have change variable by this substitution. So this integral should be converted into original variable. So we have to come back in x. So once again we use these values. Say here theta. So value of theta we will replace by sine inverse x. But how to replace value of cos 2 theta and sine 2 theta? We use trigonometric formulas. So see, here showing calculation inside, say sine theta is x, sine theta is x, so cos 2 theta. Now cos 2 theta we want in terms of x. So cos 2 theta in terms of sine theta can be expressed as 1 minus 2 sine square theta. We know this result. We have chosen this result because we are having value of sine theta. So 1 minus 2x square. So this is cos 2 theta. That we shall replace here. Theta is sine inverse x. Theta sine inverse x. Theta that will be replaced by sine inverse x. We also need a cos 2 theta. Sorry, sine 2 theta. Sine 2 theta is 2 sine theta into cos theta. That is 2 sine theta into root 1 minus sine square theta. So putting value in terms of x, sine theta is x, 1 minus x square. So putting these all values, integral is minus 1 by 4 into theta. Theta is sine inverse x. Minus 1 by 4, this is theta. Now what is cos 2 theta? Cos 2 theta is 1 minus 2x square plus 1 by 8 into sine 2 theta. What is sine 2 theta? Sine 2 theta is 2x into root 1 minus x square, and last plus c. So this is equal to minus 1 by 4 sine inverse x into 1 minus 2x square plus x by 4 root 1 minus x square plus c. It is required integral. Now see next question. Sin inverse x whole square. So whenever inverse trigonometric function is given, and because we don't have any formula to integrate sin inverse x or cos inverse x, tan inverse x, etc., always we take help of substitution. So in this question also we take sin inverse x equal to theta. You can use the symbol theta, you can use symbol t, you can use any symbol. Suppose in this question I take t, in last question I use theta. If you take t, everything will be in t. So you can use any symbol. Sin inverse x is t, so therefore x equal to sin t. X is sin t because we want relation between dx and dt. So dx is equal to cos t dt. So putting values, therefore integral is sin inverse x is t. So put here t. So it is t square. Dx is cos t dt. This is t square and dx is cos t dt. Now see, this is algebraic and this is trigonometric. Algebraic, trigonometric. L-I-A, then t comes. L-I-A-T-E. So already arranged in proper sequence. U into V. U as it is. Integral of v with respect to t minus integral of box with respect to new variable t. In box what we put? Derivative of u and integral of v. So it is box. U as it is, integral of v minus integral of derivative of u, integral of v, and integral of this product. So it is equal to t square into integral of cos t is sin t minus integral of derivative of t square is 2t, integral of cos t is sin t. So 2t sin t and its integral with respect to t. And now once again u into v, second time application of integration by parts. So it is equal to t square into sin t minus. Now because minus is main sign and we are going to apply rule of integration by parts. Applying this rule, we are getting two terms separated by minus sign. That's why use here bracket, because here also main sign is minus. Now see, u into v, u as it is, integral of v minus integral of box with respect to t, close bracket, this main bracket for second term. So u as it is, integral of v minus integral of box. In box, derivative of u into integral of v. So this is equal to t square into sin t minus 2t into its integral is minus cos t minus, here derivative is 2, into integral of sin t is minus cos t, close this box, dt, close main bracket for second term. So it is equal to t square sin t minus, this will be minus 2t cos t, minus minus plus 2 taken out. Integral of cos t is sin t, or I keep one more step, minus minus plus 2, I keep here cos t dt. And now in the next step, it is equal to t square into sin t minus 2t cos t plus 2 into integral of cos t is sin t plus c. Then opening this bracket, because we require more space, I am removing this next question. So it is equal to t square into sin t minus plus 2t cos t, then minus 2 sin t plus c. Now from these two numbers, sin t is common. So t square minus 2 sin t plus 2t cos t plus c. Now we have to come back in x. So see, here what is t? T is sine inverse x. That we will put here. T is sine inverse x, sin t is x. So sin t is x. Sin t will be replaced by x. And so cos t is square root of 1 minus sin square t. So putting values, integral is t square sin inverse x square minus 2, keep bracket, into sin t is x plus 2t, t is sin inverse x into cos t, cos t is root 1 minus x square plus c. So this is required integral. Now x into cos inverse x upon root 1 minus x square. See again, here it is cos inverse x. So remember, in integration, whenever you find inverse trigonometric function, take help of substitute. So in this question also, we are taking cos inverse x equal to t, or use theta. Cos inverse x is t, therefore x equal to cos t. Therefore dx equal to derivative of cos t is minus sin t into dt. Now putting values, integral is x is cos t, cos inverse x is t, upon square root of 1 minus x square is cos square t, x square, so keep cos square, dx is minus sin t dt. See again, this is x, x is cos t, cos inverse x is t, 1 minus x square, so cos square, and dx is minus sin t dt. Convert everything in terms of new variable when you assume new variable t. There should not be mixture of a old variable and a new variable. So it is equal to here cos t into t into minus sin t dt upon this will be root sin square t, it is sin t. So this will be cancelled. So it is minus t into cos t dt. Now LIA, this is algebraic, then trigo. Algebraic, this is trigonometric. LIA comes first, then trigo. So this we take as u, this we take as v. So u into v, u as it is integral of v minus integral of box. In box, derivative of u, integral of v, close box, and integral of this box. U into integral of v minus integral of box. In box we put derivative of u into integral of v with respect to t. So then derivative of this product. So it is equal to minus t into integral of cos t is sin t minus integral of this is minus 1. Derivative of minus t is minus 1 cos t sin t dt. Integral of cos t is sin t. So this is minus t sin t plus integral of sin t dt. So that is minus t sin t plus integral of sin t is minus cos t plus c. C keep at last when you remove last symbol of integration. Now coming back in x. So see, now we are going to put t will be replaced by cos inverse x. Cos t will be replaced by x. Cos t will be x. And sin t will be replaced by square root of 1 minus cos square t. So integral is minus t. T is cos inverse x, sin t is root 1 minus x square minus cos t is x plus c. So this is required integral. Now see, this is algebraic function a. This is trigonometric function sec square x, and we have formula for integral of sec square x. Integral of sec square x is 10x. Whatever you choose as v, it should be easily integrable. So that's why we are choosing this as v. Algebraic, trigonometric. A comes first, t comes next. So using u into v, u as it is integral of v minus integral of box. In box, derivative of u into integral of v. So it is x into integral of sec square x is 10x minus this is 1 into integral of sec square x is 10x. Then x into 10x minus this is 10x. Now integral of 10x is log mod sec x, put plus c. There is one more question. See, question is find integral of tan inverse x. See, inverse is given, so take tan inverse x equal to t. Tan inverse x is t, so x is tan t. X is tan t, so dx is sec square t dt. So this will be tan inverse x is t, dx will be sec square t dt. Now look this question. Now you can do this by same way. So what will be its answer? Performing this procedure, its answer will be t into tan t minus log mod sec t plus c. And then don't forget to convert in x. At last you convert in x. Okay, so you can finish it. Now here log x whole square, this is composite function of log x. Log x is as an inner function. So when log x is given as an inner function, take log x equal to t. Log x is t, therefore x is equal to e raised to t. Remember, whenever you take log x equal to t, take x equal to e raised to t, because here base is not visible, so it is considered as e. When here it is not mentioned, it is natural base. Log x is t, so x is e raised to t. Whenever you take substitute log x equal to t, take x equal to e raised to t. So dx equal to e raised to t dt. So integral is x. What is x? E raised to t. X is e raised to t. What is log x? Log x is t. So t square. What is dx? Dx is e raised to t dt. So see, this is x. This is log x square. This is dx. So joining this is equal to e raised to t, t square into e raised to 2t dt. E raised to t into e raised to t is e raised to 2t. Now see, L I A T E, exponential, e raised to 2t is exponential and t square is algebraic. T square is algebraic function, e raised to 2t is exponential function. So t square left, e raised to 2t on the right side, t square we should take as first function, e raised to 2t we should take as a second function, and already arrange in proper sequence. So considering this as u, this as v, u as it is integral of v minus integral of box with respect to t. In box, derivative of u, integral of v, derivative of u, integral of v, and integral of whole box. So it is equal to t square into, now its integral is e raised to 2t upon coefficient of a t minus integral of, in bracket, derivative of t square is 2t Here its integral is e raised to 2t upon 2 dt. This will be cancelled. So t square by 2 into e raised to 2t minus t into e raised to 2t dt. Now once again we apply rule of integration by parts. So it is equal to t square by 2 e raised to 2t minus, now use bracket, u as it is, integral of e raised to 2t with respect to t minus integral of box, close bracket, u as it is, integral of v minus integral of box, in box derivative of u, integral of v, so it is equal to e raised to t square by 2 into e raised to 2t minus t into integral of e raised to 2t is e raised to 2t by 2 minus integral of, in bracket, derivative of t is 1, integral of e raised to 2t is e raised to 2t by 2, closed bracket, dt, then close main bracket. So this is t square by 2 e raised to 2t minus t into e raised to 2t by 2 minus 1 by 2 take outside, integral of e raised to 2t dt. So that is t square by 2 e raised to 2t minus t into e raised to 2t by 2 minus 1 by 2 into integral of e raised to 2t is e raised to 2t upon 2, last put plus c. Now opening this bracket, t square by 2 into e raised to 2t minus t by 2 into e raised to 2t minus minus plus 1 by 4 into e raised to 2t, e raised to 2t common, plus c. Taking here LCM, LCM is 4. So this will be 2t square minus 2t plus 1 into e raised to 2t. E raised to 2t can be expressed as e raised to t square. Because coming back in x, we are going to put e raised to t equal to x. And t is log x. So now, t is log x. In the beginning we have taken t is log x and e raised to t is x. This values we are putting back. So 1 by 4 t is log x whole square 2 times log x plus 1 into this is x square plus c. So this is required integral. Now new rule, integral of e raised to x into bracket, e raised to x into bracket. Now what bracket contains? Bracket contains fx plus f dash x, e raised to x into bracket, bracket includes a function plus its derivative. So integral of such function is e raised to x into fx plus c. So let us understand in this question. Say here e raised to x, so this is e raised to x Look here, sin x, and besides sin x, this is its derivative. This is fx. This is fx, this is f dash x. Derivative of sin x is cos x. Derivative of fx is f dash x. So you can match this function with this pattern, e raised to x into fx plus f dash x. So whenever besides fx, if its derivative is given in bracket and here into e raised to x is given, then by this rule its integral is e raised to x into fx. So e raised to x into fx plus c. In this question, say integral of, say whenever you are given e raised to x and besides e raised to x there is a function of x, always try to apply this rule. In any question of integration, if e raised to x is given and besides e raised to x, if a function of x is given, combination of x is given, then always try to apply this rule. So here this is e raised to x. Now this remaining part, this part we try to convert in this pattern. So split up this part in such a way that one part is fx and other part is f dash x. So we are splitting this in two ways, that here whatever we will have it will be fx and here we need f dash x dx. We need this pattern. So we are trying to split up this part which is besides e raised to x in sum of two parts such that one part is fx, other part is f dash x. So for that, see what we do here, this is 1 plus x whole square. Now here x is given, dx is given. I have done nothing but to split up this in two parts. What I do here, add plus 1, subtract 1. Adding and subtracting 1, value remains unchanged. Now divide individually. X plus 1 upon 1 plus x square is 1 upon 1 plus x, and here minus 1 upon 1 plus x whole square, and say here this is fx, this is its derivative. Derivative of 1 upon x is minus 1 upon x square. So its integral is e raised to x into fx plus c by this rule, e raised to x into fx. This side here e raised to x into this is given. We try to convert this in such a way that here one part is fx, other part is f dash x. Whenever e raised to x into a function of x is given, combination of x is given, convert that number, split up that number, try to split up that number in two parts such that one part is fx and besides fx this must be derivative of this number. So doing in that way, say here 1 plus cos x. 1 plus cos x is 2 cos square x by 2. 1 plus cos x is 2 cos square x by 2. Denominator is taken in terms of x by 2. So same we do in numerator. This number I express as 2 sin x by 2 cos x by 2. Now dividing individually, e raised to x into this will be 1 by 2 sec square x by 2, and this will be 2 cancelled, cos x by 2 cancelled, tan x by 2. Now look, you can see that derivative of tan is sec square, derivative of tan x by 2 is sec square x by 2. Supposing this as x, derivative of tan x is sec square x, but it is not x, so into its derivative, so 1 by 2. So this is f, here e raised to x into this part is f and this part is f dash x. This is our fx, this is its derivative f dash x, you can see here. So e raised to x into fx plus f dash x is e raised to x into fx plus c. Sin inverse 2x upon 1 plus x square. Say here you can find matching of this part with a trigonometric formula. You can match it with 2 tan theta upon 1 plus tan square theta. So its matching is with 2 tan theta upon 1 plus tan square theta. It is sin 2 theta. So we take here, substitute x equal to tan theta. X is tan theta, so dx is sec square theta d theta. Derivative of tan theta is sec square theta. So integral is sin inverse 2 tan theta upon 1 plus tan square theta, dx is sec square theta d theta. So it is equal to sin inverse, this is what it is, sin 2 theta into sec square theta d theta. So it is equal to, now sin inverse sin 2 theta, put 2 theta into sec square theta d theta. Now consider this as u and this as v. So u as it is, integral of v minus integral of box derivative of u integral of v, close the bracket, d theta. So that is 2 theta into integral of sec square theta is tan theta. Integral of sec square theta is tan theta minus integral of, now derivative of 2 theta is 2, integral of sec square theta is tan theta d theta. So that is 2 theta tan theta minus 2 into integral of tan theta. Now it is integrable. Integral of tan theta is log mod sec theta plus c. C we keep at last. Now coming back in x, see theta is here, x is tan theta, so theta is tan theta we shall replace by x, so theta will be tan inverse x, and sec theta will be square root of 1 plus tan square. So putting values, 2 into theta is tan inverse x into tan theta is x minus 2 log modulus sec theta is root 1 plus x square plus c. Now square root is always positive. So 2 into x into tan inverse x minus 2 into, now root 1 plus x square is 1 plus x square is to half. So half taking down. So 2 into half log 1 plus x square plus c. So it is 2x into tan inverse x minus log 1 plus x square plus c.